This week, we speak with Tim Mackey from Synopsys. In the news segment, we have a bevy of bugs from mega bounties to giga breaches, a return to basics with WAF and Nmap, and more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. Make sure your team is prepared to fight off the latest cybersecurity threat. IT Pro TV is the resource to keep you and your IT team skills up to date. You can stream IT Pro TV courses live and on demand, so there's no need to send staff to off-site training. Team subscriptions include Pro Portal, so managers have full control over your team's training schedule. Go to itpro.tv/ASW and use the code ASW30 to try it free for 7 days and receive 30% off your monthly membership. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences. Demand more from your WAF. Learn more at signalsciences.com/PSW.
Welcome to Application Security Weekly. This is episode 86, recorded November 25th, 2019. I'm your host, Mike Shima. I'm here with Matt Alderman.
Good morning, everyone.
Good morning. And we also have John Kinsella. Hey, John.
Hey, how are you?
Doing well. Register for one of our upcoming webcasts with Kevin O'Brien of Great Horn or Steve Lobenstein of Core Security, or both, by going to securityweekly.com. Click the webcast dropdown and select registration. If you have missed any of our previously recorded webcasts, you can find our on-demand library by selecting On Demand from the webcast dropdown. If you attend any of our webcasts, you will receive 1 CPE credit per webcast. We're currently running our annual listener feedback survey. Please visit securityweekly.com. Click the Survey tab and select 2019 Listener Survey to submit your responses. Tim Mackey is a Principal Security Strategist within the Synopsys Cybersecurity Research Center. He joined Synopsys as part of the Black Duck software acquisition, where he worked to bring integrated security scanning technology to Red Hat OpenShift and the Kubernetes container orchestration platforms. As a security strategist, Tim applies his skills in distributed systems engineering, mission-critical engineering, performance monitoring, and large-scale data center operations to customer problems. He takes the lessons learned from these activities and delivers talks globally at well-known events such as RSA, OSCON, KubeCon, DevSecCon, DevOps Days, and the IoT Summit. Tim is also an O'Reilly Media published author. Hi, Tim. Thanks for joining us.
Good morning, Mike. That's quite the bio.
Morning.
I need to talk to someone about making that a little shorter.
Well, you've been to a lot of conferences. That's pretty impressive. And you've been speaking on quite a few topics, it seems. And I think one of those topics, actually, IoT Summit and IoT in general. We don't really talk about that as often, I think, here on Application Security Weekly. So I'd love to start to I think we don't need to say unravel, because I think IoT perhaps is a bit of a mess already. But let's unlock some of the mysteries of IoT, and even from the perspectives of both consumer IoT as well as enterprise. So with that setup, let's dive in and I guess maybe ask the first question. When you're thinking of IoT, or when you go to present it at one of these conferences, what's one of the first messages you want to really send about the IoT ecosystem?
So the biggest challenge that we see when it comes to IoT in general is just the complexity and speed of development. Effectively, what we have today is the moral equivalent of a nice land grab going on, where no matter what a device could potentially do, there's at least a half a dozen, maybe a dozen vendors who are actively pursuing it. And whatever they're doing, that might not necessarily be core to their business. So security isn't necessarily front of mind as much as feature function. and keeping pace with whatever the next new thing is kind of a bit of a challenge.
Well, and there's definitely with IoT, especially with as you describe it, so many vendors or organizations going after particular features or trying to provide those. Just I guess that brings up a couple things already. You mentioned, maybe security isn't front of mind, but I think that means that unfolds into a lot of different topics. And I guess one of the things too is just that aspect of if they're releasing on a fast-paced at a fast pace. What about patching? So even there, what does patching look like on IoT, both from the perspective of sitting around watching the tumbleweeds go by, waiting for a patch, as well as what about the dangers of just applying patches without testing?
So I think one of the things we probably want to do is set up what the ecosystem looks like. And I've prepared up a little bit of a slide. I'm going to try and share it. And what it kind of shows is let's get over here, some of the decision points that come into all of this. So if let's just say that the team has decided to make a shiny new IoT device. It does whatever it does, and we're going to be very agile in our development paradigm. And we're going to try and apply to the best extent possible all the DevOps, DevSecOps development mantra into this as well. What we kind of have to recognize is that there's decisions that are actually, let's call it a little bit left of the developer. So starting out, I'm going to choose that IoT device. And that IoT device is going to be a pretty limited computing environment. It's going to have a lower powered processor. It's going to have limited RAM. It's going to have maybe not even something that runs an operating system that most people would be familiar with. So it's not an embedded Windows or an embedded Linux or an embedded BSD type environment, but it's actually more of a true embedded system. To the left of that developer who's going to be writing the code to it is a hardware person. And that hardware person is actually tasked with making certain that the device is going to be really stable, but also is going to meet whatever the budgetary requirements are. So in making the statement of, I want a shiny new IoT device, I'm effectively layering a few things in. So for example, I'm going to need to configure that. That might be scanning a QR code, and that QR code is going to then have my mobile device go and pass some Wi-Fi configuration settings to that IoT device so that it can go and connect to the Wi-Fi. And immediately what I've got in place now is that device has to support Wi-Fi, and it probably needs some form of Bluetooth interface. So those are two stack elements that need to be put in place. The device is going to communicate with a something, and that something is probably going to be a web service of one form or another. And that communication protocol should be something that's efficient for the device. So maybe a full-blown TLS stack just is way overkill for what that device can handle. So something that's smaller, like an MQTT, might be something that is a reasonable alternative. There's obviously some analysis engine in the middle, and then we need to see the UI and perform whatever reporting that's in there. But you mentioned about updates, and the updates can come in effectively two forms. Either I'm going to come up with a mechanism by which I distribute new firmware updates, which is going to be a little more common in the enterprise scenario, or I'm actually going to have an over-the-air push of whatever that new firmware is. And which one that someone actually ends up choosing has direct bearing on what the future upgradability of that device is, because whatever the current constraints are and feature function requirements may not necessarily be compatible with that hardware in 2 years' time, but nobody really wants to be replacing all of their hardware as they move forward. So this is kind of a lot of the decision points that end up coming into play whenever we say, I want to do IoT.
No, that's really cool because it introduces a bunch of different areas to start to dive into from threat modeling, both on just that sense of that initial configuration, because there's that idea of we need to trust on first use, and how do we establish some secrets, or how do we establish some configuration that isn't predicated on hard coding a secret or hard coding a password in there. And then I want to dive into a little bit more about that update aspects. But I think, John, you wanted to start to join in.
Yeah, so this is I've been spending a lot of time on IoT stuff recently. So this is I'm happy we're talking about this. Is a really interesting topic to me. So I think what Tim was just showing is really interesting. What I'd love to do is, one more question for you, Tim. Curious your thoughts on when we think about this and all the questions which Mike's starting to lead into about patching all these type of things and security in IoT even. Are you thinking about this, or are you talking about this, or Synopsys, any of the above? Are you thinking about this from the point of view of what I refer to as retail or consumer IoT, or more on the industrial side, or I think it'd be really interesting to keep that in mind for this conversation, is where's the balance between those two things? I was at some show 2 weeks ago, Cyber Expo down in Santa Clara. There was an IoT conference co-located, and one of the vendors had like a light bulb on their desktop, and they were talking, or on their display, and they were talking about security. I'm like, really? You've got consumers paying for security on that? And they're like, well, sort of. They don't want to be standard thing, front page of New York Times. But I'd be really curious to get your take on that from day in, day out.
So day in, day out, we're seeing a lot of enterprise IoT, reasonable amount of commercial, and the industrial IoT is a different type of beast. And I'm going to kind of block that one off with one of the realities of the industrial ecosystem, and that's the lifespan of those devices is really measured in decades. So what we might hear about in terms of IoT in an industrial setting is a lot closer to what we would have had for industrial control systems of some form, say 10 years ago, that someone's gone and slapped a marketing badge on top of it. So a lot of the same paradigms, a lot of the same security requirements are going to be in place that they were a while ago. And that's partly due to the educational requirements that are going to be necessary at the plant level. So the control systems themselves will need to be aggregated, and that's the level of security that we're seeing. What's happening at that aggregation point, or what's happening at that control plane point. Within the commercial side of things, it really is much more that land grab, and that how do I actually ensure that whatever data is being collected is appropriately secured in some fashion that a consumer would be able to understand and expect. On the enterprise side, it's much more about the serviceability of the devices within the construct of, well, I really want these things to at least have a amortization lifespan that's rational for some device in my environment. I don't want to be having to retrain my users on how to book a conference room from the device every time that there's an update. I want to understand how that access to a corporate system, like say an employee directory, is going to be managed such that there's no data bleed. So a lot of things related to privacy in an employment environment.
And Tim, besides the communication aspects of these systems, right? Because we got Bluetooth and Wi-Fi and other protocols. One of the challenging areas that I think is sitting there under the covers is this whole firmware component, right? Because we were not running traditional operating systems in most cases. It might be an Android or an iOS, and we might be lucky if it's running that sophisticated of an operating system, right? I mean, we're talking firmware, truly embedded kind of firmware kind of systems, and that has a whole different nuance from a security perspective that most of us in the space aren't used to, because we can't take our traditional OS-based approaches and wrap some security around these devices.
Correct. And one of the first things that we recommend is that when you start talking about a production run of a new board to do whatever, let's say that it's a digital thermostat of some form, or an IoT-enabled thermostat of some form, that initial production run and the design associated with the boards that are in place, that's going to measure in the many, many thousands of dollars just to get your prototypes in place, and tens of thousands of dollars for that initial production run. where you're doing that essentially vetting process. So getting it right from the outset is very different than in a software world where we can fail fast and fail early, and we can apply a DevOps principle on top of it where we're iterating towards success. In the hardware world, that hardware is kind of locked whenever it's first set. So getting it right from a security perspective really means ensuring that the device is stable under adverse conditions. So if I've got my Bluetooth stack, I've got my Wi-Fi stack, I've got, well, let's actually leave it right there. What happens if I have a really poorly configured access point that just shovels random garbage at this device? How stable is it going to be? How stable is that Bluetooth interface? Does that Bluetooth interface need to be on all the time? So there's threat modeling aspects, but there's also protocol specific stability requirements, because let's just say, for the sake of argument, you were to throw a lot of malformed TCP packets at the device. It might exhaust all of its memory and then essentially fail in a unrecoverable manner short of a power reset. And so that's some of the, quote, denial of service type paradigms that you might have to contend with.
Yeah, you bring up a really interesting point on the circuitry, right? Is because you produce it to do a certain function, and then you run these chips, and then you're kind of stuck with what you have, unless you go to a different type of architecture, like a field programmable gate array, right? Where you have some level of change that you could initiate through these devices, but I don't see those in a lot of IoT devices. So you're kind of stuck with whatever hardware is in these devices in most cases.
Correct. And it really is a case of, instead of going to an FPGA type paradigm, we're going to do as much stuff in software as we can because the incremental cost is relatively low. But from the outset, you need to be thinking about what the serviceability of the device is, because while you can apply DevOps principles and have sprint-based release schedules that might push updates through some form of OTA, the reality is whatever those constraints at on the device at its inception are going to be those constraints in terms of feature function for the lifespan of the device.
Yeah.
And how much of that, that firmware angle, how much of that do you see we as a kind of a security industry, in fact, have regressed a bit in terms of just what the security components or security primitives are that are available within that firmware? And I'm thinking things like ASLR, or even just stack canaries, something as basic like that, so that it to a degree, the DevOps team building this firmware has a lot fewer tools available to them in terms of just how they can build a more robust foundation for that Bluetooth stack or that TCP stack, so it doesn't, so we don't reintroduce that ping of death type of vulnerability.
Well, there's that, and there's also the reality most of the devices are programmed in a C or C++ type environment. And in addition, because the devices themselves are going to have that firmware that's shipped, a lot of vendors are looking at what that actual IP that might be associated with whatever feature function. And so they're going to try and have what's known as an electronic fuse in place to prevent someone from reading out something that they ought not to, or having some encryption algorithm on top of it, so that even being able to debug what is actually running becomes problematic in the field.
Yeah, I think I want to start to expand our view a little bit of this ecosystem, because we have been talking about like a specific device, the firmware, the Bluetooth stack on it. But you had touched on a little bit of the data. So there's no data bleed, as you described it, coming off of these devices, as well as these are at an enterprise scenario. These will be distributed throughout an enterprise. And now we start to just have those situations of, how do we actually go and enumerate that basic asset inventory of all the IoT devices on a network? And then that leads us into what I started with, what we'll eventually come back around to, the idea of, how do we know they're well configured, or how do we know they're patched, and how do we just keep track of, rather than one device, 100 devices, or maybe even 1,000 if they're distributed out through a building or even a campus?
So there's really more of a procurement kind of question in my mind. So once you've decided that you're going to want to have a specific type of device, and that might be, we'll just kind of latch on to the conference room booking blocks that you see in a lot of larger enterprises these days. And for those of you who aren't familiar with it, they're basically tablets, mini type tablets that are attached to conference rooms that have a green light or a red light on them, and indicating whether the room is free or theoretically occupied, and gives you the potential to actually book a new meeting into that room. Those devices went through some form of IT vetting process. It went through a procurement. It went through maybe a bake-off of some form to go and have it selected. Now, hopefully it wasn't just the selection process was I go to Amazon or Best Buy and I find the cheapest one that I can get, and that's what I'm going to use. If during that vetting process, what is the security of that device? What is the data interchange of that device is part of the assessment process. And that whatever that protocol might be, whatever the data collection requirements might be, whatever the configuration requirements might be, are actually part of that procurement decision-making process. Then we can start to ask some really interesting security questions like, is there a phone home mechanism? What is the mechanism by which it checks for updates? Does it have any, you had mentioned ASLR, are aspects of it compiled in a way that would allow for an ASLR type paradigm to exist? What kind of stack guards are in place? Things of that nature. Because a lot of those can actually be vetted when you have a new piece of firmware, which then gets to the question of how are they going to be updated? Is this something that is under control of the enterprise or is going to be pushed down by the vendor directly? And if it's pushed down by the vendor directly, how do you control it? So all of those end up being part of the decision matrix as both threat model as well as procurement decision points.
Yeah, and if we could get all of our procurement folks integrated with the security folks, it would be a lot easier to do that, having spent a lot of time doing third-party vendor management. I know that doesn't happen in most organizations, but it would be a really good place to learn some of that before you bought the device.
And in reality, the forcing function could be, well, we're going down these independent devices. We're no longer going to have quote unquote dumb conference rooms or dumb conference systems or what have you, badge strike systems. So given the proliferation of devices that is part of a modern enterprise and the proliferation of devices that's part of the consumer experience today, one of the things we're strongly advocating for is that decision matrix that lives within the procurement space being something that is now a cooperation between the IT organization and procurement.
Yeah, that really highlights that that third-party supplier, or that that vendor security that you guys have been talking about is really important, especially that because there's a very big distinction between are updates coming from the vendor or are updates coming from within the IT organization, because that opens up a lot of questions just about ingress versus egress connectivity, as well as what's the security of my vendor, because we're talking about like a perhaps like an IoT device for scheduling conference rooms, but when we start to get into badge readers, as you mentioned, or especially cameras, security cameras, we've seen in the news those have been notorious as a target for taking over and watching other organizations. So that becomes pretty interesting to me. And I think I had a question along those lines, but what was going to be, you started to mention about things that you recommend. And so one of them was bringing in security team and IT to talk during the procurement process. Are there some other proactive steps that a security team can start to take that either is sandboxing these devices or going out to the IoT vendors themselves and different ways of building up that firmware or vetting that firmware or something else that's on top of that stack?
So it really is, at this point, much more of a conversation. So the vendors definitely want you to buy their stuff. There's no question about that. And so using that as part of the conversation piece around what has changed, what should I expect, is really a key consideration. More so when you start to look at regulations like the California Consumer Protection Act or GDPR, where there's now an incentive at the regulatory level to actually get data management and privacy, quote, correct. And the bigger challenge is around things related to consent. So if I go and get a shiny new device because it's Black Friday and I want to go and get a shiny new device, I'm going to have some form of click-through agreement. And there's no chance that my mom's going to be able to figure out what that agreement says. So she's just going to click on it. I might review it just slightly, but I wanted the device, so I want to make it work. So I'm going to accept it. That kind of blind acceptance of an agreement, if it's one device to one person, I can consent to whatever's in that. Where things get really, really complicated quickly is whenever we start talking about multi-use scenarios. So if I'm in an enterprise and one employee goes and agrees to the click-through agreement at install time, and then some point in time later, there's a firmware update and there's another click-through agreement, is that employee authorized to change the intent? Or is there an expectation that the intent is remaining the same? Has there been any change in privacy statement? Similarly, has there been any disclosure of what might be in place? I can't remember who said this, but it was maybe a week or two ago that I think it was someone from Google was saying, I would advise everyone to disclose to their visitors at Thanksgiving that a digital home assistant is in the room because it might be recording everything that they say.
Wow.
That's a paradigm that just it's hard to grasp around what the privacy implications of that might be.
Nothing like having your guests click off on a EULA or sign off on a privacy statement as they walk into your house for dinner.
Yeah. Here, give me the green bean casserole. I'll click, yes, done. But from a privacy perspective, we're kind of getting to that point where who is controlling what and who is disclosing what is a much thornier problem to solve. And if nothing else, the regulations that we're seeing are forcing that discussion point out into the open.
Well, and that's interesting because we've shifted a little bit now from the enterprise to consumer side of the IoT space, which, to be fair, there's nothing stopping these consumer IoT devices from being connected into an enterprise organization, whether they have been blessed by IoT or not. But talking about the data handling or those features, because you're alluding to what if the EULA changes, but often I guess what I'm trying to say is there are a couple of reasons that EULA could change. One is due to external regulations, updated privacy policies, just something that is policy related. The other aspect could be that maybe there's actually a new feature within this device. And this was actually a firmware update or another type of software update that has now opened up a new feature that has actually changed the threat model that the original IoT device was based on. So do you see those types of concerns quite a lot as well with these types of features, or do these IoT devices tend to remain relatively static in their abilities?
So that's a yes kind of answer. So if we go back to the beginning of the conversation, I was saying how the devices are going to be locked at the point of design, that the hardware is fixed in place. That then creates an incentive for the vendor to go and say, well, I want that hardware to be able to address all of my expected functionality over the course of the lifespan of that device. And initially, for example, there might be no audio recording, or there might be no data from a specific type of sensor that would be part of that solution. But in anticipation of future functionality in a year's time or 2 years' time, they might include a microphone, or they might include a sensor that, say, records the temperature of the room or has a camera or something similar to that. So now you have the potential of, at initial deployment, it's disclosing a number of capabilities that simply don't exist, which might potentially tip the hand to competitors. Or you're faced with downstream the scenario where, well, now we have to disclose that we had a camera in there all along, and potentially somebody could have done something interesting with it, and we're now just getting around to it. And so that really comes back to the whole data management, data privacy side of things, because knowing what's been collected is important, and collecting too much just gives vendors oftentimes an incentive to get creative with the data that they've already got.
So one of the things that I was that appealed to me to talk about IoT is that we've actually shifted from a lot of discussions we have about the cloud. But what you're just describing just now, like this data collection, data analysis, typically, and I think it's almost safe to say 99% of the time, the data analysis isn't necessarily performed on the device. That data is shipped back to a cloud somewhere. So what have you seen in terms of the the more mature ecosystems that companies have available to them from these cloud providers, but versus the way that the IoT devices are actually able to interact with them? For example, you'd mentioned like possibly even just not a really good TLS stack that they support.
So the devices themselves are rarely going to be performing complex analysis themselves. And that's partly due to hardware and partly due to context. So on the hardware side of things, you want the cheapest possible hardware that's going to satisfy the requirements. And that's probably going to be, even if it's a general purpose processor, it's going to be a lowly clocked one with a limited amount of RAM on it, just because. That then leads to, if I wanted to get any kind of historical trending information, there probably isn't enough data storage capability in the device to go and figure out what historical information would be appropriate, let alone be able to display it to someone. Because that might mean having a massive datagram going over to a smart device, for a smartphone, for example. So all of the analysis is going to be on a cloud service someplace. And that's where we can get into a very agile DevOps paradigm where you have the raw data going in, and over time, you're able to infer and evolve the feature set to do cooler things with the data that you've already gotten. And that's where you start to get into a really slippery slope with data management, because how long are you going to retain that data for? What are you going to whose data is going to be used to train the algorithms to determine that they're actually coming up with interesting answers, things along those lines.
Yeah, I think that means also too that you're going to have to pull in security and IT and procurement again to not only talk about the IoT device security management, but what does that cloud environment look like and what the data is sitting there? Because I guess I'll just mention really quick that if it's sitting on a cloud service provider and they have a SOC 2 Type 2, that is not transitive into the application running on top of that. But that sounds like, Tim, that you've got to, I think we'll have to have you back, because it sounds like there's a lot more things to dive into on that slippery slope. So until we can get you back, are there places, are you speaking at any more conferences, anything over the next couple of months where someone could come find you or hear more from you?
If anyone happens to be at Black Hat in London next week, I will be speaking on Wednesday about topics related to privacy in software design.
That's awesome. I love London myself, so always looking for an excuse to go see that. And privacy by design sounds equally important.
Yep.
Well, thanks again, Tim, for joining us.
You're welcome, Mike. And everyone.
I want to thank Matt and John as well. And I want to thank all of you listeners for joining us. We're going to take a quick break, and we'll return with news of the week.